Okay, lecture 5. We are continuing in Bash because we didn't discuss arrays, how to make arrays and use arrays. Now, I've taken this from the linuxconfig.org with some of my some changes. Only I could write a sentence like that. You have to.
Someone spike your peanut butter.
I think I had peanut butter in the brain. Okay, create an array, indexed arrays. So actually, this is an important concept that you should all know or come to know, and that is there's such a thing as an associative array and an indexed array. In C++, we just have indexed arrays, as far as I know, but there's such a thing as associative arrays. So indexed arrays are where the keys are ordered integers, like 1, 2, 3, 4, 5. Those are called the keys of the array, or what you might call the indexes of the array. But you can have also an associative array where the keys are not numbers, but strings, which is kind of weird. That's all it means. They're just strings. So that I can have an array at element location apple, and then I could have the value will be peanut butter at the array at location apple. Or I could even have more interesting things I could do with it is like with a number at that location. So for example, I can have an array of like location, Volkswagen, and then I could have 7, which means that like I sold 7 Volkswagens that day, or the company has a stock of 7 Volkswagens. Then I could have array at location, Ford, and it'll tell me I have 4, and I have a number of 6 there. I mean 6 Fords. So I can actually store like 2 pieces of information in one array by using an associative array. I associate between the word Ford or Volkswagen a number or a string. So these are a second kind of array. So and it's very useful if you get good at using it. It can be very useful for programming. Create an index or associative array by using the declare statement. Use declare command. For example, declare minus a or my array. That makes an array. A is an object creates an indexed array. Array just stands for array. Sorry, A stands for array. And the name I gave it is my array. I can use the capital A, which will make me an associative array. So lowercase is an indexed array and capital A is. This is the only way to create an associative array in Bash with the capital A. You can create a regular indexed array in another way too, but this is the preferred way to create one. Okay. Create indexed arrays on the fly. Well, here's the other way of doing it. I can just write my array equals parentheses foo bar. So now I've made an array where the first element is foo and the second element is bar. I can also, as my first command, just write my array of place 0 is foo, even though I never declared it. Just by writing my array parentheses 0 or bracket 0 equals foo, I've made an array essentially with one element. Array options. Print the values of an array. Let me change this view to larger.
Are these arrays dynamic?
Yes. In other words, I can expand and contract these arrays. This is kind of the advantage of compiled languages in general. I mean, in Java, I think you can do that too. But Java is like a hybrid of a compiled. It's not really a compiled language either. Anyway, to display all the values of an array, well, we saw this syntax before, actually, in one of my examples. But you do echo, dollar parentheses, my array, bracket, ampersand, close bracket, close brace. So that will be, and there's sort of a logic to it, like the variable, the single thing that is the array, but here I didn't write a number, but I wrote like this ampersand means like the whole thing. I can even do like this with a star, which means like the star essentially matches, says match every single one, everything that's there. Notice it automatically knows the length of the array. I don't have to tell it how many elements are in the array. Both syntax let us access all the values of the array and produce the same results unless the expansion is quoted. In this case, a difference arrives. In the first case, when using the ampersand, the expansion will result in a word for each element in the array. This becomes immediately clear when performing for loops. As an example, imagine we have an array with two elements, foo and bar, like this. So if I do a for loop with quotes here, I will get, with the ampersand, what I want. I'll loop through all the elements of the array. Excellent. That's what I intended, right? But if I do it with this asterisk, it will not work right. It will take this whole thing as a single string. So it'll only loop once. I will be assigned the value, the entire list of elements in the array, which in this case is foo and bar. Here, I got like one by one each element. That's the advantage of using the ampersand. Now, I think if you wouldn't use quotes, it would always work like this. In other words, I'm not sure, but anyway. It is also possible to iterate over part of the array with the new double parentheses operator. So if I made my array again like this, I can declare an array like this, foo and bar. Notice that's an indexed array. And then I can say, well, once I use this new operator, I already have like C++ style for loops. And that's what I wrote here, C++ style for loop. Remember, this is not a range that we learned before. This is like this new style with parentheses. New, when I say new, I mean 20 years, 25 years. Do echo my array at place I. So I'm not getting the whole array at once. I'm just creating a list of numbers and I'm just running through the array. It only prints me 2 because that's all there are. So even though I goes up to 5, it doesn't print anything for the other ones. The same is valid. A question? The same is valid for associative arrays. Retrieval order may differ from order in which declared. Right. In other words, there's no guarantee, since it's an associative array, there's no real guarantee of the order of these things. There's no numbers. Element foo is banana and element bar is coconut. That's what I created. That's how I create an associative array, by the way. First, I declare it, and then I declare it like this. For key is just a variable name. For key in, now what is this? Notice.
It goes backwards through the array.
Well, what am I printing here? I'm printing the keys. I don't know why I skipped a line here. I skipped this line. First, I have to explain this. This, without the exclamation mark, means the whole array, which would print me foo and bar. But with the exclamation mark, prints me the keys. So it's actually going to print me the key of foo and bar, which is 0 and 1. Index will get the value of the keys of the array, 0 and 1. So too here. I use the exclamation mark, and I'm going to get the keys. But the keys in this case are foo and bar. But it printed me bar and foo. As I said, the order is not provable. Not determinable. So, but the point is I got the keys, not the values. The value of foo is banana. Getting the size of an array. number of elements. My array equals foo bar bus. Okay, we made an indexed array with those 3 elements. Echo, the array contains 3 elements. So I do number sign, not exclamation for the keys, but number sign for the whole array. And again, all this is inside of a variable. It's like these are actions that I can do inside of a variable. And it's the variable which is of type, array. If I try to do this on a, I don't know what it would do if you try to do this with something that's not an array. But anyway, recall that this gives us all the elements of the array. Right. So by putting the dollar here, it's the number sign, sorry, not dollar sign, number sign tells me, give me the number of elements in the array. The adding of the number sign before the array name, we retrieve the number of elements in the array instead of its content. Adding elements to an array with the plus equals. So here we can like append things. So if I have an array foo bar and then I do array plus equals bars, then all of a sudden my array is foo bar bars. Okay, multiple elements can be added at one time. I can do foo bar and then I can do plus equals bars foo bar. So now there's 4 elements in my array. Add elements to an associative array, we must specify the associated keys. Now, you can't just add elements and let it create keys for you if it's an associative array. Because what are the keys? The keys, you have to specify the keys. So if I make my array foo is equal to bar, then I'd have to say like this, add more elements to array plus equals. I'd have to say the key, bars, foo bar, and foo bar bars, bars. Deleting an element from an array only by its index. So how can I delete an element? I can delete it if I know the index number. I can say unset. We saw unset before when we were seeing for variables. Now we're unsetting a variable essentially. Unset my array at location 0. Now here's interesting. So now when I print it, I'm going to get just foo and bars because I got rid of bar. 0 and 2 remain. But the weird thing is, you might think that bars became 1, that it's 0 and 1. But actually, the array has like a blank element in it now. If we check the indexes, we can now see that 1 is just missing. So my indexes, remember the exclamation mark gives me the keys. So my keys are 0 and 2. 1 is gone because I unset it. You might have thought you might have thought that bars became element 1, but it doesn't. Now the same thing is valid for associative arrays, where foo and bars are there. Notice here I use the plus equals. I didn't have to. I could have used the regular equals. And now I unset foo, and I only have foo bar in the array. I only have bars, which is foo bar. Now, if you think about this for a minute, you can realize, or 2 minutes, you can realize that actually everything is an associative array. And that's why this works. That's why this occurs. In other words, even though it's an indexed array, it's really just a special case of an associative array where the keys are numbers. And everything is, and it's defined once. Associative arrays is the basic thing. And then indexed arrays are just a special case, which allows you to not specify the key, and then it automatically takes integer values. How do you delete an array? So you can unset the whole array. And now if you try to print it, what this means is the keys in the array, you'll get nothing. After executing unset against an entire array, when trying to print its content, an empty result is returned. The array doesn't exist anymore. And here we didn't specify an index. If we had specified an index, it would be one element in the array. Okay, now some examples. After we've learned everything, we can do some examples. But, I feel like the Rambam in the beginning of Moreh Nevuchim, who tries to give so much information that nobody can continue reading. But let's continue. Okay, so I make an array of 5 elements. Array 2 has got this value, this value, this value. I don't have to write the minus a, it's the default. So in other words, when it sees these parentheses and everything, it figures out that it's an array. Now, echo, if I want to print the size of the array, I can do like this. Number sign, we saw that. The number of elements in array 2, in the whole array. What's it going to print me? 5. Now, I do the size of the length of element at index number 2. In other words, here is the whole array. Here is the size, which in this case is going to mean the length of location number 2. What's the value? What am I going to get for this line? What value?
You get 1.
No, the length in characters.
Oh, 4.
Yeah, you're going to get 4 because it's the third element is 2, and there's 4 letters here. In other words, that's another important point, which is that even if I store things as numbers, there's no type. It's really stored as characters. Everything is a character. And when I use it, if I try to do plus with it, it realizes that I'm doing plus with it. It tries to treat it as a number then. Or do addition with it, for example. But everything is stored as characters. There is no such thing as type, really. I mean, in the sense of numbers versus characters. So the size is the length. Now I do the number. This is kind of weird because I gave it the name of the array, but I didn't write the @ sign and I didn't give it an element. So what does this mean? Not clear. We didn't learn what that means. Should be either an @ sign or an element. So the answer is if I don't give it an element, it assumes the first element. So what's it going to give me here?
6.
6, exactly. Now, temp equals array to the whole thing, :3. What does that mean? All the values in the array from index 3 on. So temp will now be, well, what will temp be? This is an interesting question. Temp will not be an array. Temp will be a variable which has in it the values from 3 on, which is 0, 1, 2, 3, has these two elements. So it'll print this string, but it'll be one string. Now echo temp. Now if temp is this 4, 5, 4, 5, 5, 4, 5, 4, if that's what temp is.
Wait, I'm not so sure about something.
Yeah.
In array 2, all the way up top, these are separate elements because of a space?
Yeah.
So now, why exactly?
Yeah,
And
it's
so
a good
that
question.
space is carried over?
Why didn't this work
The
over
space is
here?
carried over in the string?
Listen, it might work. I didn't try this, but if you put parentheses here and here, then it might create temp as an array. You see what I mean? It's something special about the parentheses here, that it tells it that this is a list. So I may have to use the parentheses. I didn't try that. I could try it now. Let's try it now. Stop share. So I can do array equals, 45, 54, 65, 56, 74. Okay. Now I do echo array, dollar array, just to prove that that worked. I didn't give it the whole array. I just did the first one, see, like we learned. So if I want to give it the whole array, what if I write no, I got to put it in braces. And then I got the whole thing. Okay. So now if I do R with one R equals parentheses.
Oh, by the way, it's smaller. Is there a chance you could like make the window smaller from the top and move it up? Because Zoom is like maybe just for me, but it's like, oh, that works. Okay.
Wait, you saw what I did up to now?
Most of it, yeah.
There, that's my array. Now I want to do like this. Array equals, this is what I wanted to try. Dollar array what do we say? Colon 2, let's say. And now,
Just echo it, I guess. See what
well,
it.
if I just
What it
echo it, I'll just see what that won't prove anything. Well, let's do that first. Let's do that first, that won't prove anything, but that doesn't prove anything. That's what we thought we would get no matter what. But now the real test is if we do, for example, 1 here. Oh, see, it worked. Now it's an array, you see? Because I use these parentheses here. In other words, this is actually a very important thing. I should add this to my examples. You understand why this works? Because here it's a string, but by putting that string inside of parentheses, it will work.
It's as if we wrote out the characters with the space in between, and it turns that into an array.
Exactly.
See?
Inside the parentheses, it puts this list 65, 56, 74. And then since that's inside of parentheses, it all of a sudden decides. But if I didn't have the parentheses there, it would just make an array. It would just make a variable with that value of those strings. I'm just wondering. All right, stop share. And share screen. No, no. So where were we? We had the problem here. Right. So we have to say we can add here. Temp equals See, once you have all these tools, you can start combining them together. That's what we're doing here. This will create temp as an array of how many elements? 2 elements. Okay, so echo temp. So what is this going to, oh, so this is going on the first example. Oh, I had the order here wrong, but sorry. So here, in this example, temp is now this whole thing. If I do 0, now this is interesting. This is a range. 0 to 1, what does it mean? 0, start from 0, do 1 element. Print variable temp from index 0, 1 character in length. So it'll just print the 4 here because temp is just a single string. It'll print 0, 4. In other words, it looks like I'm saying the 0th element, the first string in it, the first letter in it. That's not what it means. It means from element 0, from character 0 of the string, of this whole string, print the first one. And this we saw creates an array of 3 long. Okay. Printing sections of an array and copying an array. So if I have my array like this, here's with my array with 5 elements, I can do echo, and now it's really an array. So now it's gonna print element 1, which is this one, 2, 3, 4, and then 3 following out, 3 total elements. So 1, 2, 3, it's not gonna print the 54, 54. So here the numbers do refer to the indexes. When it's an array, they refer to the indexes. When it's a string, it refers to the elements in the string, the characters in the string. To copy an array, you need to iterate over each element, just like in C++, right? If you want to copy an array in C++, you have to make a loop and go through each one. But actually, to save time, you could try something like this. Declare an array Q, which is equal to the whole array. Actually, we saw that. That might or might not work. Let's see. You might try this. But echo $Q0 will print the whole array because the right side equals just a long single variable. So that's what I explained here. So now I explain it again. So therefore, we have this, for convenience, we can use these parentheses that'll make it work. All right, we just saw that. That's funny that I see. There you go. Important lesson. Not a good idea to change your slides while you're teaching because you may have it already there. Except now I want to make another change. Okay. So now that works. And when I print the first element, I'm going to get just the first element. Yofi. And we're getting near the end of the bash section. Very near the end. In old bash and in TC shell, to check for a substring within a string, which is a common thing you might want to do, you need to use grep like this. So look at this funny thing I have. String my apple. If echo string, so first I send the string by echo through the pipe. And then I grep quietly for the word my. And if I find it, then this whole thing becomes true. So then it's if true, then it's there. And if this whole thing was false, then it won't print. So that's how I would do it. Now, to you and I, to you and me, this seems wonderful and clear. And it's very straightforward. Well, how else would you do it? Echo, string, put it through grep, quiet, look for my, and if you found it, great. But a lot of people who are normal think that this is complicated. And therefore, they made a newer version of Bash 20 years ago that has this double brackets. And it's the same as the test, but it has some extra features. And one of them is that I can do equals tilde. And I can just do if string equals tilde, in other words, means contains. The way you read it is if the string contains the string my, then print it's there. So that's a convenience. That was a note to myself. Okay, so we finished Bash. Now back to some Unix things. You're still alive, if your brains are still functioning. We just learned a whole programming language pretty much in a short time. We didn't learn functions, actually. Don't I do functions in Bash? Maybe I do it later. We'll get, if I don't do it later, remind me and I'll do it. Jobs. A job is a concept used by the shell. Any program you interactively start that doesn't detach, is not a daemon, is called a job. Detach means detaches from the terminal. In other words, it's running on its own in the background. But a job is any program that you start interactively. If you are running an interactive program, you can press Control-Z to suspend it. Then you can start it back in the foreground using FG or in the background using BG. The salmon, maybe. That's Bubba. While the program is suspended or running in the background, you can start another program. While the program is suspended or running, right? So if you suspended it or you put it in BG, not FG, then you can start another program. At that point, you would have two jobs running, the one in the background and the one in the foreground, or the one that's frozen and the one running. And whether it's frozen or in the background, it's also a job. You can also start a program by running the background, you can also start a program running in the background by appending an ampersand like this. Program, I should really demonstrate. I think I have another page on it, right. Here I summarize it again, but let me demonstrate now. Stop, if you don't mind. You stop share. And share screen.
I don't know about other people. I think I personally prefer seeing like these things actually running as opposed to just like on slides. I don't know, for whatever reason, it just appeals to me more.
Yeah, you can.
Yeah.
More believable. Yeah, I can do that. I can just sit there doing things, but the slides are. Yeah, I can do both. I can do that more. Okay, I'll try to do that more. So let's see. For example, I can do for this particular one. I have to show you. That's why the other ones I don't know if there's much different. But if I do, for example, it's hard to think of something to run in the background, but here, if I do WC, so WC is running right now. Even though I didn't give him anything, so that's why I didn't finish. It's waiting for me to give it something. But I can do Control-Z, and it says stopped. And now if I say jobs, it tells me that WC is a job. And now I can do, let's say, another command, what is it called? fstat? No. I don't know, top. And now I can do Control Z. I stopped it. I ran top and then I did Control Z. And now I can do jobs. Oh. And it tells me that I have 2 stopped or frozen. I, for some reason, like to call it frozen, but 2 stop jobs, WC and top. Now, I can also do the following. I can also do, what's another good command? What about cat? I can do cat, and then I can do ampersand, and it'll run it in the background. So now again, if I do jobs, I have 3 jobs running in the background. Background means they're running, but I have my terminal I can do. They're not taking up my terminal. They're not really running in the background. They're stopped in the background. Now, I could theoretically have a process running that's like calculating pi to 1,000,000 decimal places. So that could run in the background, and that wouldn't be stopped, it would be running. These ones I stopped, and they're stopped in the background. Now, if I do the following thing, FG, it puts one of the jobs into the foreground. Which one? So let's see, it put cat in. So it's a stack, right? It's a machzanit. The last one in is the first one out. It's a stack. And if I can't do FG again because this cat is in the foreground. I can kill it though. Control C will kill it. And then I can do FG and it should give me top. And it does. I can do Control C and I killed it. And now if I do jobs, I just have 1, the WC. And I can do, right, so, and now I can kill this one by doing foreground, FG, and Control C. And now if I do jobs, I have nothing. That's the basic concept of jobs. Sometimes you're doing something and you don't want to exit the program, but in the meantime, you want to check the manual page, for example. So you Control Z it, you freeze it, and then you bring it, and then you check the manual page, and then you go back to where you were by doing FG. So it's useful. That would be a useful purpose for it. And that's the concept of jobs. So here is, so here
It's a
you
little
saw.
strange. Is there nothing that will take a specific program? Like it has to go from the end backwards?
Maybe, I don't know. I
It
don't know.
doesn't
You can
seem so
look.
hard to implement, to just go through it and search for a certain command and pick it.
It might be by the number. You might say like FG1, maybe. I don't know. I never tried to do that. It makes sense that it's a stack because you want the most recent one. You just close. In other words, I stopped. It's like I'm making pancakes, and then the doorbell rings. And then while the doorbell rings, the phone rings. So now I go answer the phone. I finish the phone. I go back to the door, and then I go back to the pancake. In other words, there's a certain, when I get interrupted, I sort of want to go that way. But I don't know if there's a way to go in another way. So here are S, Control C, Control Z, FG, BG, and the program with an ampersand will also run the program in the background. Xargs, so let's do this one also. Xargs is a very powerful and interesting and difficult to understand at first thing. But let's just, like you said, let's demonstrate it. So I can do ls, and I get that. And then I can do ls. If I can do pipe into file. Doesn't work. File needs to be like file and then H1, the file name. And it tells me it's an ASCII text file. But I want to do ls of all the files. So I could just do file. The truth is I could do file star, and then it'll tell me all the files there. Because the star, the shell will help me out. The shell will turn this asterisk into all the file names. And then it's as though I wrote file and then a whole long list. And so it'll work. But I could also do it a different way. And that is ls. Again, I wanted to do ls and pipe it into file. And that didn't work. Because file wants the file names on the right side, not on the left side. It wants file. It doesn't want to get them as a standard input. It wants to get them as a list after the name of the function. It wants to get them as parameters. So if I want that, whatever comes through the pipe to be parameters, I use the command xargs, which means execute, but I do it the other way around. Xargs execute the arguments using the command file, and then it works. In other words, take the input that you got and put it on the right side. That's what xarg means. So for example, I could also do you know, I could do ls. I mean, these are silly examples with ls, but any command that I want to do over here, let's just do with ls. ls, and then I could do xargs, and then rm minus I. So I hope I didn't delete everything. No. That's interesting. Oh, it doesn't like the parameters. It doesn't like the minus I. The point is, well, maybe I have a better example. Let's see just a second. Ah, yeah. Okay. I don't have a very good example. I wish I had a better example, but I can give you some examples of using this. Just a second. So, for example, I could do WC H1, H2. So that does a word count on the H1 and H2 and tells me the total. WC is built to take multiple files. I could also do ls H1, H2, and pipe it into WC. Now, it gave me a totally different result here. Why is that? Why didn't it give me the same thing? I did pipe the files and put them into WC. Why doesn't it work? Well, let's remember, if I would do just ls like this, what would I get? I would get H1 and H2. So it essentially just sent H1 and H2 into WC as the standard input, and it counted 2 words, 2 lines. I don't know why 2 lines, but I guess there's another line here somewhere. I guess because even though printed on 1 line here, it's really 2 lines. And 6 characters, because H1 with a null and H2 with a null. So, or no, because I don't know why 6, but it doesn't matter. It printed it, it did the word count on this input, not on the files themselves. It didn't treat the H1 and H2 as parameters as arguments for the WC command. If I want to do that, I'm going to have to write xargs WC. And then it turns, instead of it being a string, it becomes a parameter for WC. So let's go back. Does that, anyone have a question about that? It's a little bit confusing, but I hope my examples clarify. Okay, so this is pretty much the example we saw. Bring it here, let me do it. So here we see ls. That was the example we saw before. Wait, let me just stop the pause the recording for a second. Okay, so these examples we kind of saw. Here, well, we didn't see this one, but I did a find every file that's a regular file in the current directory. And then on those files, run the command grep George. Look for George inside these files. So it's as though the files were on the right side. As though I wrote grep George, file 1, file 2, file 3. So the xargs throws the result on the right side. Now there's a problem with this command because it could be that I have a file with a space in it. Like in Windows, people like to write file names that are like my, example 1 or my book report with spaces. So when I throw the results of this thing to the right side, it's going to think my and book and report are 3 separate arguments, 3 separate files. But there's no file called my and no file called book and no file called report. I want it to be treated as a one thing. So it's not going to work. So how do I make it work anyway? So there's a special trick. Find has a special feature called print 0, which means that it prints a 0, a null, at the end of every file name, which it normally wouldn't do. It would normally just put a space, or a new line. It's actually going to print a null at the end of every file name. So it'll be my book report with a 0 at the end of it. And then xargs has a special command called 0r, minus 0r, which tells it to look for, to treat as the distinguishing field, the field separator, not a space, but a 0. As minus 0r means that what distinguishes the fields will be a 0, which is exactly what I got from the thing. So now it'll work for a file called my book report, because the spaces will not be the delineator. The 0 at the end will be. These are very high-level things that I'm explaining to you.
So the 0 is just like a delimiting, or is it a 0 or a null?
I love that question. Everyone always asks that question. A 0 is a null. The character null is a character, like the character A. And the ASCII value of A is, lowercase a is 97. And the ASCII value of character null is 0. So 0 is
Right.
null.
So I was asking if I guess you answered my question, but I was asking if it delimits the files with a 0 character or a null character.
Oh, so it's with a null character or the 0 with the 0 value, not the 0 character.
Right. I understand that now. That's what I was
Yeah.
asking.
Yeah, so great. It is a null, so it's the null, but I refer to it as we refer to it as a zero. Okay. Just a second. That's the end of this lecture. That's lecture 5. I'm curious what lecture 6 is. Lecture 6 doesn't exist. Let me stop the recording.